The last content standard in the integumentary system deals with skin damage. The standard reads, I can describe the mechanisms for repairing damage to the skin from cuts and burns, and this covers section 6.4 of your textbook. So, before we talk cuts and burns, we have to mention the word inflammation. Inflammation is a normal response to any sort of injury or stress to the integument. So it is a good, helpful thing. During inflammation, extra blood is routed towards an area where there's been perceived damage. So your body has ways of telling if there has been damage or cuts or trauma to an area and sending extra blood to the area to compensate. So it becomes red, swollen, and it might become painful. This also alerts you that something is wrong so that perhaps you can see if it needs attention, right? Your body is trying to restrict the spread of infection here. It's trying to send extra blood to the area containing these critical white blood cells to attack whatever pathogen might have entered your body. If you're getting cut, if you're getting kicked or bruised, there is a good chance that there's a foreign pathogen from the atmosphere that's entering into your body. And we need to get extra white blood cells to the area to fight it as soon as possible. All right, SKIN.3 skin damage. Let's start with cuts. So there are 3 different classifications of a cut, and it depends on how deep it is. So a shallow cut only damages the layers of the epidermis, so any of those 5 strata. These cuts will not bleed, and usually they heal very quickly just by increasing the rate of epidermal cell division. There's a little gap, we just divide faster and faster to fix it. So you're not seeing that in any of these pictures over here. All of these look like they've cut down into, this is a 4-step healing process rather, and the original cut was down into the dermis. A deep cut goes a little bit further. So we hit the dermis and we hit specifically blood vessels. So if you're seeing blood come out of a cut, a shallow cut might be a paper cut where it hurts or you feel it but you don't see any blood. A deep cut, you're going to notice a loss. To solve this, we need 3 things. First, we need to stop blood loss. So the first step is clot it. There are little tiny fragments of cells in your blood called platelets that can stick to each other and form a plug. That way you're not losing blood and we can focus on fighting whatever might have entered your body, but you're not going to bleed out. In step 2, we got to scab the area. So the blood on the outside will form this really dry, crusty clot, but that will be extremely protective while you're working on repairing whatever is happening underneath. And speaking of happening underneath, we have fibroblasts in the area that are secreting collagen and trying to bind the wound together. So in Unit 2, we learned that collagen was a long thread-like molecule. And so what it is going to try to do is sew up or reattach those 2 sides of the dermis that have been severed. We also have a lot of phagocytic cells that are trying to come in and consume any sort of dead cell material, whether it's human cell, bacterial cell, etc. The last step of a deep cut is you're going to have a scar. We tend to overproduce, our bodies overproduce collagen when there is damage, and so after that scab falls off, it'll look shiny, it'll look silvery, and that will be due to these excess collagen fibers. That is the reason that stretch marks appear silvery and brighter. It's the reason that we have scars and we can tell when it's not original skin. That collagen is set up in a different formation. Burns, there are also 3 degrees, and it's because of very similar reasons. How far did the burn get? In a 1st-degree burn, we're going to call it superficial partial thickness. Only the epidermis gets burned. So this is not a burn you're going to get from fire. This is like a sunburn. In a 1st-degree burn, you will see it'll be red, it'll give off some heat, it might look a little inflamed, but it will not blister if it is a 1st-degree burn. It will just be painful. A 2nd-degree burn, a deep partial thickness burn, will go down into that dermal layer. So some of those dermal structures will be destroyed. If you get a second-degree burn, it will blister, which is a pocket of like watery substance that serves as a cushion to nourish and hydrate that new tissue underneath as it regrows. And you can get these burns from maybe boiling water, um, touching something really, really hot, and perhaps even a terrible sunburn could be second degree. Third degree is a full thickness burn that gets down to most of the accessory structures in the dermis and perhaps even into the hypodermis. These burns are often so bad and all of the cells are so destroyed that they need a skin graft to heal. We'll take skin from other parts of your body and we'll move it to the part that has been burned. Oftentimes, really prolonged exposure to heat, intensely hot flames, or chemical burns can result in full thickness burns. If you are someone who is considering working in a hospital and you enter a burn unit, you will learn about the rule of nines. The rule of nines divides a human body into regions of 9% or multiples of 9 so that we can more quickly estimate how bad a burn is. This helps medical professionals decide, hey, do we need to give this person an IV? Do they need skin grafts? What is the best course of action? So you'll notice the head is 9% total, 4.5 on the front, 4.5 on the back. Each arm is the same, 4.5 on the front, 4.5 on the back. The trunk is 18 on the front and 18 on the back, a big patch of skin there. And then each leg is 9 on the front, 9 on the back. So we'll do an activity where you use the rule of nines to calculate body burn percentage and make medical decisions based on that data.